Hi, and welcome to this lecture about cost functions in logistic regression. This equation presents the question, what is the probability that the picture has an iPhone given an input x? Y hat is your estimate of what your actual value is. In the previous lecture, we have presented that our goal is to develop a neural network that can fine-tune the parameters of W and B for an input X, so that the value of Y hat is as close as possible to the actual value of Y. So how can this be calculated? This can be calculated using the loss function of logistic regression, which is presented as follows. Here we see the loss function is denoted as L, and we have Y hat, which is the predicted value, over next to Y, which is the actual value. I will not go into the details of how this equation has been calculated, but I will add a link below for those who's interested. This part is abstracted when it comes to programming, but it's important to understand how this works. The loss function calculates the Y hat value for a single training example, that is, a single image. So what is a training set, or what is the training data? The training data is the data you want to fine-tune your algorithm based on. You can take these below. So what's the cost function then? The cost function calculates the average loss for the entire training data set instead of a single training set. Here we can see that the cost function is denoted as J, and it takes in both the parameters W and B. And the equation is as follows. M here is the training set. So since the cost function calculates the loss average over the whole entire training set, we put it 1 over M. The I here represents the image position. So from the first image up until M, so let's say you got 50 images, for example. And then the first image, you get the predicted value here of the first image, and you get the actual value here. So we can see here is the equation of the loss function, which is up here again, and that is basically calculating the loss for a single data set. Now we're going to iterate from 1 to 50, and we're going to calculate the average, and that gives us the cost function of our case. So that is, in summary, the loss function and introduction to the trading data and the cost function. But there's one important thing that I also want to explain, which is the difference between a sigmoid function and a softmax function. The sigmoid function, which is denoted up here, is used for a two-class logistic regression. So in our case here, in our examples, whether the picture has an iPhone or not, the softmax function is used for a multi-class logistic regression. So if it's an iPhone, a Samsung, a Huawei, Sony, whatever. So basically, the softmax function is an extension of the sigmoid function to the multi-class case. Thank you for watching. If you have any questions, please post below. Otherwise, like and subscribe if you want me to publish more similar contents. Thank you all.